Hi, I'm Ollie, with over 7 years of experience working in top tech companies such as Amazon and Goldman Sachs. I'm here to help you level up your coding skills and land your dream job in big tech. On this channel, LeetCode LevelUp, I'll be posting daily videos to guide you through solving coding challenges and becoming a better programmer. If you enjoy the content, don't forget to hit like and subscribe and stay tuned for more. Today we're going to be looking at LeetCode question 136, single number. Given a non-empty array of integers, nums, every element appears twice, except for one. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. Example 1, nums is equal to 221. The unique is 1. Example 2. Nums is equal to 41212. The output's going to be 4. In example 3, nums is equal to 1. The output's going to be equal to 1. The approach that we're going to be taking today is using the XOR bitwise operator, and it has 3 simple rules. 1 XOR 0 is equal to 1, 1 XOR 1 is equal to 0, and 0 XOR 0 is also equal to 0. The time complexity of the solution is going to be O of n, with a space complexity of O of 1. Let's look at 4 XOR 5. So 4 is 100 in binary, and 5 is 101. So 100 XOR 101, starting from right to left, 01 is 1, 00 is 0, and 11 is 0. Now you may be wondering, how is this relevant? Well, let's take a look. Step 1. Initialize a single number. We'll call that number count and we'll set it equal to 0. Step 2. Traverse the array of nums, starting at 2. So we'll set the current number equal to 2. 2 in binary is equal to 10. So the count, which is 0, XOR 2, is equal to 10. So we'll update that. Next, move the pointer across the array to 1. Set the current number equal to 1. 1 in binary is 1. So 10 XOR 1 is equal to 11. Update the pointer. Set the current number equal to 4. 4 in binary is 100. 11 XOR 100 is equal to 111. Move the pointer. Set the current number equal to 5. 5 in binary is 101. 111 XOR 100 is equal to 10. Again, we move the pointer. We update the current number equal to 2. 2 in binary is 10. 10 XOR 10 cancels out to make 0. We update the pointer. Set current number equal to 1. 1 in binary is 1. So 0 XOR 1 is equal to 1. And finally we move the pointer to the last element in the array, which equals 4. So we set the current number equal to 4. 4 in binary is 100. 1 XOR 100 is equal to 101. 101, when converted it out of binary, is equal to 5. So step 3, we return the count. Count is 5, which is exactly what we were looking for. So well done, you followed along. I hope that that's made it a lot more clearer to you. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. So we're now in the LeetCode application, looking at question 136, single number. So given a non-empty array of integers, nums, every element appears twice except for 1. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. So when solving this, if I was in an interview setting, I think the first thing that I would do is I would clarify to make sure that we are in fact going to be given an array with at least one element, because if we're not, we're going to need to handle that edge case. Secondly, I would want to clarify whether or not we're going to be looking at positive integers in the array or both positive and negative integers in the array, and thinking of a solution that would be able to handle both of them situations. And then the final thing that I would want to sort of ask the interviewer would be, how big are we talking this array is going to be? Is it going to be millions of elements, or is it just going to be a few elements? Because obviously if it's a few elements, we could potentially use a bit more memory to improve our runtime complexity. However, if we're looking at millions of elements and we're using memory, it could end up using a huge amount of memory. So they're three sort of key questions that I'd ask. And the first thing that came to my head when I was doing this problem was using a hash map. So it would be loading the items into a hash map and then checking to see whether it had been seen before in the map, and then returning the item that hadn't basically had a duplication. However, the problem with that is it doesn't use constant extra space. So if you followed along in my whiteboard walkthrough, you'll know the solution that we're actually going to take, which is the optimal solution, and that's using XOR. So we broke it into 3 steps. Step 1, we need to declare an integer, int count, and set it equal to 0. Secondly, we need to loop through the nums. So say for int I equals 0, I is less than nums dot length I plus plus, and then we want to do count x or nums current number, so nums I, and then finally we return count. Let's see if that runs. Okay, cool. And then submit this. See if it passes all of the tests. Cool. Okay, excellent. So in terms of runtime complexity, it's beaten 99.78%, and in terms of memory, it's beaten 48.51%. Although we can see that we are using constant memory because we're just using count. But yeah, this is the simple solution, a 3-step solution to solving this problem. So if it comes up in your interview, I think you should be pretty grateful. Well, thank you very much for watching. If you liked the video, please leave a like, click subscribe, and leave any comments.